So to give you a brief idea of the roadmap for where is the course going, we'll start off by learning some Rust. It is not very nice if we were just going to just say, yep, go learn Rust and come back and we'll focus on that. We're going to talk about Rust and we're going to learn about why it helps us accomplish our goals, but we're not going to linger on it for a huge amount of time. Then the next part involves getting into the hardware and having an understanding of the ways in which hardware affects what we're doing in our program. That when we find out that a particular operation is slow or something like that, it's usually, well, we figured out that we have cache miss or something like that. We'll learn about why these things matter and how to address it, and we'll focus on the important parts. It's not intended to replace a hardware course altogether, but just to give you some insight into the way it interacts with your program. We'll talk about parallelizing well. In previous courses where you've talked about parallelizing and concurrency and things, you will have learned about the importance of stuff like locking and such when you're using threads. But in such courses, all that mattered was that you didn't have any errors. You didn't have any problems with the code you were writing, so there's no race condition, for example. Whether it was slow or not was not super important. Now it matters. Now we have to use these concepts well. It's not enough to just not have race conditions, but we actually have to do a good job of how we apply our tools, and so that will be important in this section. Then we're going to get into some more complicated things. When we start out with Rust, and then we go into parallelization. And parallelization is usually a relatively easy way to get some speed up in your program because we're taking good advantage of the hardware that we have. However, eventually we're going to run out of room on that. We have already parallelized what we can parallelize, and we've used the hardware to its maximum capacity that we have, and then we have to start getting into some things that are a little more exotic to actually extract some more performance from your program. So one of the strategies that we will talk about is the idea of speculation. We'll also think about improving single thread performance. We will also start getting outside of using just the CPU, and we will start to think about, can we use the GPU as a way of getting some more performance, doing something a bit more advanced, a bit more complicated than just regular CPU stuff. Alongside that, and you'll see off to the side there, is profiling. Profiling will be increasingly important as we go through what we're doing, and eventually it gets kind of a unit of its own a little further on in the course, where we'll talk about different profiling tools and how to use them effectively and how they work. And it helps us to identify what in our program is slow and to address it in an effective manner. Finally, we will have run up against the limit of what we can do on any individual machine. We've used the tools that we have. We've exhausted all of our tricks in terms of speeding up single thread performance. Everything is parallelized that reasonably can be, and we don't have a lot left to do. Then ultimately we will start thinking about using more than one machine. And then we get into cloud computing, which talks about how do we have multiple machines in the first place, but also something brief about queuing theory, which allows us to answer questions like, how many machines are we going to need? How many servers should we provision for our particular program? Those kinds of questions will be answered with queuing theory. So that gives us our brief high-level overview of how the course is going to go, starting out with things that are easy, moving into things that are a bit harder in terms of actually extracting good benefit of speed up, and eventually we end with a talk about we've maximized what we can do with one machine, let's use many. And that will be it for the course. So I hope this roadmap is enlightening and gives you a good idea of what we're going to do. I hope this roadmap is enlightening and gives you a good idea of what we are going to do this term.